This video is an introduction to the Commander X16 assembly language editor version 1.1. Version 1.0 came out in January, and there's been a significant number of improvements since then. This is from the editor README file, just listing some of the changes that have gone on. So let's just have a quick look at our directory. We can see that mledit.bin is in here, edit.prg, and default LBL. That's the program itself. And then in docs, we've got editor readme. That's a 99 kilobyte file, so it's pretty large. It's pretty extensively documented, everything that's in here. mledit.bin is the actual editor itself. It lives up in paged RAM. Default.lbl is the metadata file, and right now it's in 8000 to 9EFF. That'll change in the next version. Hopefully it won't take as long as this version took to make. And edit.prg is our bootstrap file. It lives in 0400 to 080F. So let's just start by loading edit.prg, 8, 1. I'm going to go through this as fast as I can because I'm trying to get this under 15 minutes, so we can see it's just a simple jump into assembly language, quick splash screen. I'm just going to blast by this, and we're going into mode 1 now. And since this is all blank, it's hard to see what the differences are between the various modes of editing here, so we'll just go to a place I know that there's code. This is mode 1. In mode 1, all branches are listed as being branches to addresses. In memory, it's stored as a relative branch, but in this mode, it's always shown as to a relative address. To switch to mode 2, just hit F4. And here in F4, any zero-page addresses that are attached to labels are shown. But it's still, you can see it's still stored as 7E7F, whatever, but it's displayed as the label in this mode. If we go F4, we're into mode 3, and this just shows 8 bytes per row along with their character equivalents if it can. If it can't print a character, it just does a checkerboard character. Hit F4 again, and now we're into mode 4, the single byte data mode, and it shows every bit in the byte. Hit F4 one more time, it's character mode. So if these were strings, you'd see the characters. Hit F4 once more. So PSTR is one of a half dozen useful subroutines in edit.prg. This one just prints a string that's located at an address pointed to by x and y of length pointed to by a. So we're going to use that later. There are also 41 16-bit subroutines in edit.prg. And to bring up all of the comments, I'm just going to type LLBL. That brings up all of the editor's own comments. Actually, it just changes a couple of pointers. They're stored in RAM anyway. And so you can see these are all operating on 7E7F as a 16-bit accumulator named W. 7C7D is a 16-bit general purpose register named V, which is sort of like the X or Y register, but 16-bit. And all of these arithmetic operations, and or exclusive or, there's sub, compare, add, the W register can shift left, shift right, rotate left, rotate right. V or W can increment or decrement or be set to 0. They can be pushed or pulled to the stacks, and all of the flags operate in the same way as the 8-bit analogs to the 16-bit files. With the exception of this one here, our swap just swaps the contents of V and W with each other. So let's just go to 0000, and you can see there's a number of registers here, 16-bit registers. I've just put default labels for all of them. The devs wanted to call this one R10, this one R11, and so forth, but that doesn't make sense, so I just named them how they should be, and go to 007C and F4, F4, F4. You can see the labels that I've chosen for the V and W registers. So let's go to 9F20. This is the Vera registers. Go data, brings us into mode 4. And you can just see that all of the Vera registers have labels attached, and there's 32 of them. I'm going to go F4 a couple of times and get out of page 9F because the emulator doesn't really like you poking around in there. So go to FECF. I had treated the Commander X16 as if it was a souped up Commodore VIC-20 with just the Commodore API in it, on version 1.0, but 1.1 I've included all of the Commander X16 API. I've added labels to all of these, and they're fairly close or logical labels based on what's shown in the programmer's reference guide. Like for instance, this one is JSR far, and if we scroll down into some of the Commodore 128 labels Commodore 128 kernel, and then the original Commodore kernel after that. And if we keep scrolling past FFFF, we're back into the 0 page. So let's go to FEND, which is our first byte that we're available to program on. And we're going to do a quick hello world program, and we're going to have it clear the screen and then print hello world 10 times. First thing I'm going to do is r/or. Oh yeah, I got to get rid of all of the editor's labels so that I have room to do my own labels, FEND. So we're going to set a label here, MYST. We're going to go down 1 byte and set another label, MYS1. MYST is going to contain the clear screen character, and then MYS1 is going to be our actual hello world. So we're going to say that this is a string 13 bytes long, 0D, and we can just type in hello world exclamation RLD exclamation mark. I had to use the up arrow key there because if I'd used backspace, it would actually show up like that. So up arrow, return, that's our 13 bytes. We'll go F4, we're going to set another label, INIT, and we're going to go to MYST. And now you can see that the string hello world is displayed as a string. So we're going to go data 93, that's the screen clear character. We go back up here at F4 a couple of times, and we say that this is now a string 14 bytes long, 0E, and there it is. Let's print that string. We're going to load A with the length of MYST. Normally, when you're entering in immediate mode like this, it's expecting 2 hex characters, but if you enter the letter L, then it'll be looking for a label, MYST, and if that label is associated with a string, then it'll return the string length. We're going to load X with, if I hit the less than sign, that indicates the low byte of a label, and Y with the high byte of the label. And then we're going to jump PSTR, and we're going to test this, and we can see it does the first hello world and clears the screen for us. So now we're going to do it 9 more times. We're going to set label STRT. That's going to call init first to clear the screen and print hello world the first time, and then we're going to load a counter. We're going to store that in the 0 page location. If the 0 page location has a label attached to it, then you can just go /R0/L. Wait, STA0/R0/L, not RO/L. If we hit F4 to go into mode 2, you can see it's displayed like that in mode 2, and all of these are just displayed as hex digits. F4, 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 F4. So we're back here. Now we're going to jump to a subroutine 0835. I've done this so many times I know exactly where it's going. We're going to decrement our counter and branch not equal to an address. And now we're going to put in our subroutine here. We're going to set a label loop. We're going to put a comment on loop. Worst label name. Seriously is. Don't ever do that. Anyway, you can see that loop is replaced 0835 in that one. Now let's load A with the length of MYS1. We'll load X with the low byte of MYS1, and we'll branch to an address 0822. So if we execute STRT, it does hello world 10 times. I'm just going to add a couple more things here to show a few more other features of the editor. Let's say that other is some subroutine that's called by some other part of your program, and it happens to use JSR far. It calls JSR far. Now, JSR far needs to be followed by a word and a byte to indicate what address and what bank that you're jumping to a subroutine in. So we're going to go word A432, we're going to go byte 1C, and since I use JSR A to get into that, it's going to return to this byte, so we'll just go RTSI. That'll get us out of there. So let's set another label here, TST. We're going to say it's a string 4 bytes long, TEST, hit F4 and set one last label, FEND. So now we got our file end set. We're going to test it one more time, make sure it still works. Yep, haven't screwed it up. Let's say we wanted to add something to the start of MYST. Let's say we wanted to add 4 characters to it. INSE04. You can see the length of MYST has changed. All of these labels have moved. Loop was at 0835, now it's at 0839, and now this points to 0839. MYS1 has moved from 0811 to 0815, and this byte has changed. So that's all automatically handled for you. Let's go data. Our screen clear moved. That's unavoidable. We'll just go up here and go 9.3, and then we'll F4 to get us into mode 5, character mode. Enter, great, F4, STRT, and there it is. So that's really quick to edit that. Let's say though that we don't like that. Let's say we want to get rid of these 4 bytes now. Okay, so we got rid of those 4 bytes. The length of mist has changed back to 0E from 1 to. All these labels have moved again. Loop has moved back to 0835. This has changed. MYS1's back at 0811. That has changed. So that's great. What happens when you do it from within the program itself? DELE03. Okay, everything moved up, and of course loop moved up. This changed, but this branch, it was pointing at 0822 before, and now it's still pointing at 0822. Keep an eye on this branch when I insert 3 more bytes here, INSE03. Note it's still pointing at 0822, but the relative address has changed as necessary. So all that's handled for you automatically. We can see it still works. Anytime you insert or delete the bytes that are shifted, if a label is encountered and a label has to move, then anything is attached to that label, like when MYS moved, this one changed. Any branches that need to change automatically. It takes a lot of the pain in the ass factor out. So let's save this. Are you sure? Yes. If we look in our directory, there is now a hello program and a hello.lbl. That's the metadata file that has all of your labels and comments and so forth. So let's quit. Are you sure? Yes. I'm just going to completely close out the Commander X16 editor and reload it. And we'll get it back up on the screen here. And we're going to load and run it, and it puts us right back into the editor and loads up all of our labels so we can continue working on this. But what if we decide that we just we're done, that this is our final state of this program? 08OD, when we looked at the basic program to start all of this, it was sys 2061. In hex, that's 080D. Currently it jumps to the start of the edit.prg to load up the editor and stuff like that, but we can change that to STRT. And now we'll save this as hello2.prg. Yes. Press any key to continue. Alrighty, so I'm just going to quit. Yes. And Control R. So once again, we're going to load hello, and you can see that that one goes right into the editor. .prg, and that one just executes our program. So that's basically the gist of it. I go into a lot more detail in the editor README file. It's very, very extensive, and happy programming.